É um prazer estar aqui, introduzindo os nossos palestrantes dessa sessão. O primeiro palestrante é o Dr. Bernd van der Meulen. É professor de Direito Alimentar, tem formação em Direito Público, abrangendo Direito Administrativo, Direitos Humanos, Direito Europeu, Direito Internacional e Direito da Concorrência. Sua principal competência é na dimensão jurídica das ciências da vida em geral e na legislação alimentar em particular. É consultor privado em assuntos jurídicos de alimentos e professor de Direito Alimentar na Universidade de Wageningen, na Holanda. Possui especialização em Direito Alimentar e assuntos regulatórios, combinando o know-how legal e científico. Please, Dr. Bernd, would you come to the stage here? Thank you for accepting our invitation to come down.
Thank you, very, very kind introduction. I would like to thank also the organization for inviting me, for having me here. I think it's a great honor to be part of this team and to be part of this conference, and to share with you that among the food sciences, there are also the legal sciences. A few things have already been said about me, and I included a slide with some more information. So first few seconds I will dedicate to myself. I will dedicate to an organization called the Global Harmonization Initiative. And then I would like to frame the content of my presentation in the context of an invitation to you to cooperate with me, to cooperate with us in a concrete publication project which is designed to understand how food science is integrated, plays a role, can play a role in regulatory issues. And from there onwards, I will discuss where we stand today, how we got there in terms of development, what the WTO is legally doing with food science, what the Codex Alimentarius is doing, how it is decided where science should play its role, and then some examples on how these affect categories of foods, how this affects conditions of food, what can be said about risk communication, and how to look at institutional aspects. And maybe, if time allows, I should remain closer to the microphone, they tell me. Time allowing, I might make a final remark on the concept of precaution. I promised to start with myself. I provided some websites where you can find some more information. I teach and research everything where food and the legal sciences meet, but also practice what I preach as a volunteer at the food bank in Amsterdam. Those of you who are interested in food legal affairs, I would like to point to the Ibero-American Food Law Association. But finally, I decided to place today's presentation in the context of the Global Harmonization Initiative. The Global Harmonization Initiative is mainly a network of scientists, of concerned scientists who believe that regulators create a lot of damage by irrational decisions framed as legislation. And the ambition of GHI is to voice, as far as it exists, scientific consensus towards regulators, hoping to contribute in such a way to better global legislation on food. And you all, if you feel attracted to this way of thinking, are welcome to join. At least if you are in a situation where you can act independently, where you can have an own opinion, irrespective of your employer. And this slide, in fact, elaborates in a little bit more detail how we see this and how we believe that it may contribute to positive things. voicing scientific consensus. Well, we are scientists, if a lawyer may say so. No, thank you very much. Yes. We do through publications. We find here some books that have appeared so far, and I would like to invite you to contribute to the next volume, a volume on risk analysis, on the method how science is involved in regulation, and we would like to understand to what extent this methodology is recognized globally and is applied globally. And to come to a better understanding, we aim at some case studies of specific requirements expressed in numbers, such as a maximum residue limit for a pesticide crop combination, or a natural chemical food product combination, or a microorganism food combination. And the reason to choose legal requirements expressed in numbers is that numbers are so easy to compare in terms of whether they are same or different. And also, numbers are often based, not always, but often based on a calculation. And if you can retrace this calculation, it may help understand why things are different. If it is in the data, if it is in the quality of the science, if it is in objective differences that may explain why in one part of the world food safety limits must be different than in another part of the world, or is it just political choice? And if it is choice, maybe it would be possible to negotiate and compromise. To be able to make this global comparison, we would need knowledge and understanding how things are being done in the EU, in the US, over here, in Asia, in Africa, and that can only be achieved in a network. So once again, I invite you to consider yourself part of this network. As an author, as someone supplying information, as someone helping with the language, as someone contributing in the peer review, so that for this once we will have sound science instead of what we just had. Now, what are we talking about when I say risk analysis? The question how food technical science should affect the regulatory activities raised concerns in the United States in the 1970s and 1980s, which resulted in a study from the National Research Council, the so-called, the famous Red Book, trying to make sense, trying to come to some kind of consensus in the specific context of carcinogenity of chemicals, how this should be approached. In this report, in this Red Book, it has been presented that first of all, a distinction should be made between two elements. The scientific element referred to as risk assessment, the decision-making element, regulatory element, political element, however you want to call it, which was labeled risk management. The question was asked if an institutional separation between those two functions would be beneficial. And at that moment in time, this question was answered to the negative, that probably putting science and decision-making too far away from one another might have more negative impacts than positive impacts, because communication between the two would be crucial. This concept of communication, I'm running ahead of myself. First of all, the Red Book phrased the language that has been common, that has become common today on what risk assessment is all about. It consists of these 4 elements: hazard identification, what at that moment in time they called dose-response assessment, exposure assessment, and risk characterization. But they also went into the question, when? When should science play its role in regulation? And the answer should come from what they call risk assessment policy. How to do it in a scientific, sound way, and when to do it. And when running ahead of myself just now, I was thinking of the next contribution to the building of the conceptual framework by the National Research Council on this concept of communication between the elements of risk assessment and risk management, which already in that time was framed as an interactive process, a process of questions that are actually respondent, of opinions within the whole decision-making process from the inside and from the outside. To rephrase it in my own words. Now this concept, as defined in the 1980s, has been taken up by the WTO, the World Trade Organization. And when we want to look at legal developments globally, the WTO is a good starting point. WTO addresses our field of activity, the field of regulating food safety, in the so-called SPS agreement, the agreement on the application of sanitary and phytosanitary measures. And even though the WTO is an organization that almost has a religion of free trade, it does recognize in this particular document that there are things in life that are more important than free trade. And among these things in life that are more important than free trade are life and health of people, life and health of animals, life and health of plants. So the SPS agreement recognizes that it is justifiable when members of the WTO put in place barriers to international trade if those barriers are necessary for the protection of life and health of people, animals, and plants. Now, how are we going to establish what is necessary in life? Lawyers have no instrument to come to such an assessment. Professor Korn just indicated when scientists are hired by a bunch of lawyers, probably what you get is not always sound science. But maybe the movement has to be made the other way around. The answer that the SPS agreement gives is that necessity has to be established on the basis of science, has to be established by those people who understand the difference between safe and unsafe, between toxic and not toxic. Or alternatively, you as a member of the WTO, you as a member state are okay in regulating on food safety if you do the same thing that everybody else is doing, which means if you follow international examples, if you follow international standards. In particular, those standards that have been agreed upon in the context of the Codex Alimentarius. In the following 3 slides, I have copy-pasted the articles from the SPS agreement to prove that what I'm claiming here is actually in the text of this regulation. This is the closest thing where the legal sciences come to reproducibility by showing here actually it is being said. So members do have the right to take sanitary and phytosanitary measures if they are necessary. the showing of necessity has been based on science, and also the continuation of these measures have to be based on science. And a measure means any rule, any requirement that affects trade. Well, any requirement that you make on the safety of a food may affect all products that enter your country, and therefore may affect trade. And it's okay to do so if you have good reasons, or if you follow the harmonized examples of, in this particular example, the Codex Alimentarius. And don't try just now to read all the words on the slide. The presentation will be made available to you, so you can check out in more detail. Which brings us to this particular Codex Alimentarius. We've started from the Red Book, from the scientific thinking on the concepts that should be on board in the setting of food legal standards. We see it taken on in the WTO, saying if you do it based on science, the result is not considered an unjustifiable barrier to trade. And if you do it according to the Codex Alimentarius, it is considered proper under the WTO. Now, the Codex is combining these way of thinking, and on this slide I've shown that the terms included in the definitions of Codex are exactly those terms that have been developed earlier on. Terms of hazard, terms of risk analysis, consisting again of the assessment, of the management, and this third element of risk communication. The risk assessment consisting of these 4 steps. And finally, again, the communication framed as an interactive process among all stakeholders, including society, including businesses, including the academia. So probably everybody has seen this picture, something closely resembling it, representing the 3 elements of risk analysis according to the Codex. What is so interesting about this picture is that everybody is using it in their publications. It then goes on to tell a totally different story, in particular on the point of risk communication. We will come back to that point a little bit later onwards. I promised to dedicate a few thoughts to when are we going to apply these methods. In terms of the Codex Alimentarius, that is the issue of risk assessment policy. Risk assessment policy, the decision that risk assessment is called for in the Codex is considered part of risk management. So is considered part of the responsibility of political decision making. In the context of the Codex, that means the Codex Alimentarius Commission. In the context of national legislations, that means the legislator. This choice has to be made in advance, and risk assessors receive their mandate from risk managers. To come closer to the basis of the decisions underlying the trigger, the putting into action of risk assessment, I think it may be valuable to distinguish the area of food safety into 4 categories, where it's important to realize that when we talk about the safety of a food, we may address very different aspects. We can talk about a product as such. Today we have addressed, for example, products that result from biotechnology, with all the criticism that has come to bear. But there the question is about the category of foods that results. If we talk about aflatoxins, also an example that was used, we are not talking about a category of foods, we are talking about the condition of an individual food that has been contaminated. Now this distinction between looking at the category and looking at the individual product reflects also in rules and regulations. Then it's relevant to distinguish between issues that have explicitly been tackled by regulators and an overall notion of safety for what has not explicitly been tackled. In the EU, it is required that food must be or must not be unsafe. In the USA, food may not be put into commerce if it is adulterated. What this means is the burden of businesses in all those situations where the legislator has not explicitly spoken. So one important step in risk assessment policy is assigning a certain situation, a certain category of food, its proper place within this framework. As to categories, I listed on this slide some global examples of categories of food considered in need of risk assessment by legislators. To the best of my knowledge, the USA were the first, towards the end of the 1950s, by framing the concept of food additive and putting it separate in the world of foods. Food additives have to be authorized before they are allowed to be put in the food. And what is a food additive in the North American language? A food additive is anything added to food, with an important exception. If scientists have already reached consensus that it is safe, if it's generally recognized as safe, it is not a food additive within the meaning of the US American system. Where they have introduced a challenging notion, which I have not found anywhere else in the world, but which is potentially hugely important, that on the basis of scientific consensus, you can stop being worried about a certain category of food, even without going through the regulatory process. The Codex Alimentarius has the same way of thinking about food additives. They should not be used except after science have found them safe, but they use a much more narrow concept of food additive. It is not anything added to food, it is only that which is added for a technological purpose. And this is not the time and the place to elaborate too much on what a technological purpose is, but it's certainly smaller than anything. And this smaller scope has been adopted in the EU as well, and has been found too small. Has been found too small mainly under the influence of the advent of gene technology and all the concerns that followed it, at least in the EU. So next to this concept of food additive, a second concept was introduced: novel foods. Anything that our parents didn't consume should not be placed on the market except after it has been found safe by scientists who are qualified to do so. Intended first to cover products from biotechnology. Biotechnology appeared to be too politically sensitive to be dealt with within this framework, so it has been given its own separate framework. In the People's Republic of China, also food additives are under an obligation of prior risk assessment, even though the definition of food additive is again different. And Similar to the EU, they also adopted a concept of novel food materials, where the word material probably covers something like ingredients, additives, anything that you use in food. All these categories put aside by legislators have in common that the sponsor, the business, the developer that wants to come to the market with this product has to provide evidence of safety. And well, you are all involved, or half of you, in establishing the safety of food products. So you have the feeling that having this burden of proof is quite a barrier to market access. On top of this, in China, in Russia, in Indonesia, to name a few countries, all foods on the market must be registered and must be covered by a standard and must conform to this standard, adding yet another layer of regulatory issues. Now, if we move to the conditions, the lower half of the quadrant that I showed, I would like to lift out as example the regulation of radioactive contaminants. Two students of mine have done comparative studies of the codex of the EU, the USA, Indonesia, Japan, Australia, Canada, to see how this issue is regulated. And what we find is that in most countries they take a starting point conforming to the SPS agreement in international standards. At the international level, risk assessment is undertaken by the International Commission on Radiological Protections. On a regular basis, they update their findings and recommendations. Legislation always lingers behind. Legislation may use the most recent recommendations as a basis, which means that newer legislation will be based on newer science than older regulation. Already one element why finding is different. At international level, Codex Alimentarius is again the source for standards. At the national level, this has to be translated into the local situation. An important point for calculating the national situation is the worst case scenario. In the worst case scenario, which percentage of the food supply does the regulator expect to be radioactively contaminated? In most countries, this percentage is set at 10%, believing that even if there's a nuclear disaster, chances are low that more than 10% of the food supply would be contaminated. Japan, after the Fukushima incident, chose to calculate on the basis that the entire food supply could be contaminated. So if you have consensus on the acceptable level of exposure of humans in the legislation in Japan, the maximum acceptable level per food product would have to be 1/10 of elsewhere in the world. From there onwards, what kind of choices do legislators make? In most countries, including the EU, distinction is made between foods that are consumed a lot and foods that are consumed rarely. The more often the food is consumed, the more critical the standards. If it's just herbs and spices, somewhat higher level of contamination would be acceptable. And of course, food for infants, food for the elderly is again regulated differently. Not so in the USA. In the USA, it has been decided that there's one level over the board for all food products. And the rationality behind this decision is in terms of enforcement. You don't want enforcement agencies, enforcement officers to face the challenge to measure all different foods differently. If you choose just one level for everything, it has to be a level that is fit for infants also, that's fit for the elderly also. So we see here political decisions, enforcement-related decisions that contribute to explaining why levels are different globally. A little detail between the EU and Japan. EU has its standards based on 10% of the food supply. One exception, to imports from Japan, a level is applied equal to the Japanese standard, which is much lower, where the thinking is, if you consider it not good enough for yourself, we are not going to buy it from you. Different numbers, different food products, different places in the world. Partly you can explain them, partly you can reconsider if we wouldn't be all better off if we came to some kind of harmonization. Another topic that caught my attention is the topic of zero tolerance. Dr. Cohen mentioned the wisdom that toxicity is always dose-related. Now, it is one of the ambitions of the Global Harmonization Initiative to make regulators understand this topic. Regulators, legislators, politicians often have this Pavlov reaction: if something is toxic, it should not be in the food supply. Not being aware of the damage they create if they express themselves explicitly in terms of the number zero. Under development in science, zero becomes ever smaller, and zero becomes ever more untenable as a normative standard. So from this background, I was curious to find out where and why is zero used. And in the field of veterinary drugs in the EU, we indeed found situations where, after scientific assessment, no lowest effect level could be found. But we also found situations where you had a veterinary drug that was no longer supported by the producer, and if no new data are forthcoming for the regulatory system, well, there will not be a registration. And if there's not a registration, it is not supposed to be present in the food supply, and not supposed to be present in the food supply can be translated into that number zero. And then there are those antibiotics in particular that are reserved for human medicine, where the decision has been made it should not be used for animals, and therefore, in fact, by way of enforcement instrument, the legal level allowed in products is this level zero. More enforcement than science, and we've seen the absurdities to which it can lead, to shipments of shrimps that were destroyed in the harbor of Rotterdam because there was a contamination in parts per billion of chloramphenicol. And of course, with all the political issues that resulted from the exporting countries. I promised to return to risk communication. You remember the 3 circles? You will find them in a whole number of publications. And interestingly, when the author continues to explain, in half of the publications you will find information on how difficult it is to explain to consumer food safety hazards, in particular in the context of genetic modification. And in the other half of the publications, you will find the explanation on the interactive exchange of information and opinion within the risk analysis process. So this lady, Adina Baiku, also a student who looked into it, came to the conclusion that the concept of risk communication has two phases that many people are not aware of, so they speak the same language, using the same words, thinking totally different thoughts. In the context of the book writing project to which I invited you all, these kind of questions can be asked. How, in your context, is risk communication understood? How is it applied? Is it in a part of risk management in terms of telling the consumers what to do and what not to do? Or is it a part of the risk assessment policy? Risk assessment practice. In the EU, I hear a lot of complaints from businesses in particular that the risk assessment by EFSA, by the European Food Safety Authority, is a black box. The question goes in, at some point a result comes out, and they consider it next to impossible to have this interactive exchange of opinions and information during the process. Is this a typical European issue, or does it happen elsewhere, and how do you deal with it? Now this finally, almost finally, this issue, how should risk assessment and risk management in the legal process relate to one another? Have we seen in the Red Book that the position was taken, close communication between the two is more important than an institutional separation. In its statement of principle, the Codex Alimentarius has taken a different position. They believe that the separation between risk assessment and risk management should be respected in order to ensure the scientific integrity of risk assessment. You see that JECFA, GEMRA, GMPR, and also the new body, which name I now forgot, on nutrition issues, are explicitly separate from the Codex Alimentarius Commission. Science is an input for the Codex. It is not in their hand. Totally different is the FDA model. In different aspects, it is different. FDA is broad in scope, in that apart from food, it covers all kinds of other products. It is broad in competence. Risk assessment, regulation, enforcement are all in one hand. No institution separation. Again, in the EU, we find a clear separation of risk assessment from risk management by granting responsibilities of risk assessment to the European Food Safety Authority. They do only science. They do not decide. They, therefore, are not in a legal sense an authority. But it sounds good to call them such, and I think they have acquired some authority in a more moral sense of doing, well, with you sitting here, I don't dare to say good science, but at least maybe some acceptable work in the terms of risk assessment. We see that many countries in the world follow these models from either FDA or JECFA, EFSA. In China, for example, up till now at least, we find a mixed model, which at its center is the Chinese Food and Drug Agency, I think it is called, which has the same broad scope as the American FDA, but there's more separation of functions between risk assessment and risk management, where risk assessment is placed with the Family Planning Commission, which is the new, not so new anymore, name of the former Ministry of Health. However, China is going to change everything. Just last month, just tomorrow, 1 month ago, they decided to group everything together that has responsibilities in the field of food safety. So at this moment, the new regulatory infrastructure in China is somewhat of a black box. I have no idea how I'm doing with time, but the last or topic that I want to touch upon, at least, is precaution. Precaution is a flag that is often waved in the context of where science and regulation meet. I included here a quote, and I see that I misspelled his name. My apologies to Neil Fortin. N-E-A should it be, not N-E-I. One of my American colleagues, in his book, Food Regulations, Law, Science, Policy and Practice, he makes this remark that in a strict usage, any uncertainty on safety prohibits a potentially risky activity until it is proven safe. And then he doesn't say it, but usually when this remark is made, the following remark is, and you cannot prove a negative. Well, that may be a little bit a not completely fair representation of regulatory systems in the world. Yes, under authorization requirements, prior proof of safety is required. But you can only require proof of safety if you have at least some inkling on what is accepted as evidence and what is accepted as a negative outcome. Toxicologists can come, in my simple understanding as a lawyer, to a conclusion whether or not to label a substance at a certain dose as toxic. If Europeans talk about precautionary principle, they do not refer to this prior requirement of science, but rather to the situation, what if risk assessment has been performed by competent scientists and the outcome is still unclear. And on this slide I quoted from the provision in the European General Food Law, where following an assessment of available information, the possibility of harmful effects on health is identified. Scientists found possibility of harmful effects, but scientific uncertainty persists, then measures can be taken. So the better safe than sorry wisdom is here used to grant powers to regulators to take measures where there are reasons to believe that there might be harmful effects, but still the science is open. I think I would like to leave it at this.